any moving object that is being acted upon only by the force of gravity is said to be in a state of free fall. Free fall is an example of a uniformly accelerated motion. There are two important motion characteristics of free-falling objects. First, they do not encounter air resistance, and all free-falling objects on Earth accelerate downwards, and its acceleration due to gravity is equal to negative 9.8 meter per second squared. The three kinematic equations for free fall will become Vf is equal to Vi plus Gt. D is equal to Vit plus 1/2 Gt squared. And Vf squared is equal to Vi squared plus 2 Gd. And the five variables will be Vf for final velocity in meter per second, Vi for initial velocity in meter per second, D for vertical displacement in meter, G for acceleration due to gravity, which is equal to negative 9.8 meter per second squared, and T for time elapsed in second. Let us now solve sample problem number 1. In an amusement park, a drop ride falls freely for 2 seconds after starting from rest. Find its, letter A, velocity at the end of 2 seconds, and letter B, displacement covered at the end of the drop. To answer the question, we will first write all the given information. So final velocity is unknown, and then the initial velocity is 0 because it is starting from rest. And G is a constant, negative 9.8 meter per second squared. And then time is 2 seconds. And displacement is unknown. To answer question letter A, we will use the formula Vf is equal to Vi plus Gt. Substitute all the values to the formula. So this becomes unknown is equal to initial velocity 0, and then negative 9.8 meter per second squared times time, which is 2 seconds. So this will be 0, and then negative 9.8 times 2 will give us a value of negative 19.6 meter per second. Negative because it is on a downward direction. To answer question letter B, we will use the formula D is equal to Vit plus 1/2 Gt squared. We'll now substitute all the given information to the formula. So this is unknown. Initial velocity is 0 times time, which is 2 seconds, plus 1/2 negative 9.8 meter per second squared times 2 seconds squared. So this will now become 0 minus 19.6 or equal to negative 19.6 meter. Negative because its displacement is downward. We can also answer this question using the formula Vf squared is equal to Vi squared plus 2GD, wherein to substitute all the information or the values in the formula. So for the final velocity, we'll be using this one, the one that we have just calculated. So negative 19.6 meters per second squared is equal to the initial velocity 0 squared plus 2 times 9.8 meters per second squared times d, the unknown. Okay, so this will become 384.16 is equal to negative 19.6 d. Transpose this to the other side. This will be divided by negative 19.6. Divide this by negative 19.6. So this will become 1. So d will remain here. So our final answer therefore will be equal to negative 19.6 meters. Again, negative because it is on a downward displacement. For sample problem number 2, I will discuss a type of free fall motion wherein an object is thrown vertically upward with an initial velocity of 30 meters per second. And we will prove through calculations that on its way upward, its velocity has a positive value and will be decreasing until it becomes 0 at the highest point. And then, from the top, it will change to downward direction. Its velocity will be increasing and have a negative value. And that the time of flight upward is equal to its time of flight downward. And as it returns to its starting point, its velocity will be the same in magnitude but opposite in direction. With the given situation, let us now solve the following questions. Letter A, how long will it take to reach the highest point? Letter B, what is the highest point it can reach? And letter C, what is its velocity when it has returned to its starting point? To answer question letter A, we are going to use the formula Vf is equal to Vi plus Gt, wherein the given is the initial velocity, which is 30 meters per second, and we are going to determine its time of flight upward. So we know that once it is at the highest point, its final velocity will be 0. And initial velocity will be 30 meters per second plus g is negative 9.8 meter per second squared times t, the unknown. Okay, transposing this to the other side of the equation symbol, this will become plus 9.8 t, then plus 9.8 t. Okay, so this will become 0, and this will be 30 is equal to 9.8 t. Transpose this to the other side. We'll divide this by 9.8, divide this by 9.8, so therefore time of flight therefore will be equal to 3.06 seconds. So its time of flight upward will be 3.06 seconds, and its time of flight downward will also be 3.06 seconds. For question letter B, we are asked to determine the highest point it can reach. So, we are going to use the formula for letter B. D is equal to VIT plus 1/2 GT squared. Wherein we will now substitute all the given information to the formula. So this will be unknown. So 30 meters per second times time. Okay, the time of flight upward, which is 3.06 seconds plus 1/2 times negative 9.8 meter per second squared times 3.06 seconds squared. So this will be 30 times 3.06 is 91.8, and this one 1/2 times negative 9.8 times 3.06 squared will give us a value of negative 45.9. Okay, so our displacement therefore will be equal to 45.9 meters. For question letter C, we are going to determine the velocity once it has returned to its starting point. So we are going to use the formula for letter C. Vf is equal to Vi plus Gt, wherein our Vf is unknown and our initial velocity is 30 meter per second plus g, which is negative 0.8 meter per second squared times, okay, once it has returned its starting point, that means it has already completed its time of flight upward and time of flight downward. So our time therefore will be the total time of flight, which is 6.12 seconds. So this will become 30 minus 59.976, wherein our final velocity therefore will be equal to negative 30 meter per second. Negative because it has the downward direction. We can also solve this problem using the formula Vf squared is equal to Vi squared plus 2Gd. Okay, so we will now substitute all the given information to the formula, and the unknown is squared, so we are going to extract the square root of the whole expression. So this will become Bf is equal to the square root of Okay, initial velocity will be 30 meters per second squared plus 2 times 9.8 meter per second squared times 0. Why 0? Because it has already returned to its starting point. So its displacement is equal to 0. So therefore, this will be the square root of 30 squared. So our answer therefore for final velocity will be positive and negative 30 meter per second. So we are going to discard the positive because it is going on a downward direction. So our final answer therefore will be equal to negative 30 meter per second for a downward direction. So that's it. Thank you for watching and please subscribe now.